So in the yesterday's topic about the OSI model, anyone has any questions, any doubts? So if there are no doubts, then we'll proceed ahead with one more model, and then thereafter we'll start a very powerful topic known as subnetting. So this is something called a TCP/IP model, and as like in OSI model, there were 7 layers. Over here in TCP/IP model, it composed of 4 interconnected layers compared to the 7 layers in the OSI model. As you can see on the screen over here, it has 4 layers. Which are those 4 layers? They are application layer, transport layer, internet layer, and network access layer. These are the 4 layers in TCP/IP model. Each layer performs a specific task on the data that is being transmitted over the network channel. Whenever the data transmit from one end to another end, each layer performs a specific task where the data moves from one layer to another layer, similar to the OSI model. So we'll quickly discuss these 4 layers and jump into the important topic, which is subnetting. So when you talk about the application layer, it is the closest to the end user. Usually, an end user has a PC or a laptop. What he does is application layer is a layer where the application resides. The best example is he opens a Google Chrome or any other browser to browse a specific site. So basically, the application layer provides the interface for the end user, and similar to the OSI model, over here the protocols which are supported are HTTP, HTTPS, FTP, SMTP. Then there is a transport layer which ensures that the data delivery is reliable and there is no error while transmission. And it is same. The protocols which are supported there, the same protocol are supported here as well. That are TCP and UDP. TCP provides reliable connection oriented delivery. Error checking is there. If there is any kind of error, then the data is retransmitted. So we have discussed the three-way handshake, which happens in TCP. But UDP, there is no guarantee that there will be no errors. There is no guarantee. There can be error, but it is fast. And we have discussed about the examples also that TCP is being used where like you need to ensure that there is no data loss. The best examples are your emails, or you can say when you are browsing a specific website where you want to load the data. But at the same time, if you're watching YouTube as a user, you don't want the video should stop, then again should start. There should be a continuous streaming. In that places, usually the UDP comes into the role. And another example which we have discussed was about the voice telephony, the voice over IP. Nowadays, you are seeing that you have a IP extensions phone on your desk. So this uses the UDP, and it is not administrator who defines. It is by default ensured by this layer approach that whether the communication will happen over a TCP or a UDP. Now, in the voice, when you are calling someone at that time, if let's say the TCP protocol is being used, transmission control protocol is being used, and three-way handshake comes into the role. So just imagine you say hello, and the time it reaches to the end user, it will be a lag. That is the reason over here we use UDP. Wherever there is a fast communication is required, and you can bear that if there is any sort of data loss or anything, then there should not be any issue. In that case, the UDP protocols come into the role. Any questions over here? So you can see that what was there in OSI model, application layer, presentation layer, session layer, all is being merged as an application layer in TCP IP model. Then transport layer is a transport layer, network layer is changed to the internet layer. And as over there we have seen the role of the network layer, it handles the routing. Here also it is same, the internet layer handles the routing of the data packet. It uses IP addresses to be uniquely assigned to the devices, and it determines the best path to travel across the network. And then comes the network access layer, which was data link layer plus the physical layer. In the TCP/IP model, it is a network access layer. So this is the lowest layer in the model and responsible for physical connection between the devices, which we have discussed already in OSI model as well. Now we'll consider one live example, and then we'll straight away move to the subnetting part. Now consider when the user consider a user, and let's say this is a server. This is a user, and this might be www.google.com, for example. This is a server. Now the user sitting over here opens the browser, calls for https colon www.google.com. The protocol which comes into the role is https. The user will send the data through an application by opening a website, and the application layer, the very first thing what will happen is application layer will prepare the data for transmission using https protocol. Once this application is called by the user over https protocol, then the transport layer will come into the role, and what it will do, the actual request will be broken into the small segments, right, and the sequence number will be added over here. And then it ensures that a reliable delivery, TCP is required for the fast connection, or UDP is required over here. It will ensure. Finally, the internet layer will come into the role where the IP addresses and all will be assigned, and then the network access layer where it converts into frame, add the MAC addresses, and then converts into binary addresses, zeros and one, and the communication is established between the user and this website. Any questions, any doubt over here on TCP IP model? Yes, anyone has any questions, any doubts? If everything is clear, then it's the right time to move to the subnetting. Now, before we move to subnetting, we need to discuss small topics and get clarity. We have discussed about classes of IP addresses, right? In our first or second lecture, classes of IP addresses. Can anyone tell me what are the classes of IP addresses? Please put in the chat box what are the different classes of IP addresses we have discussed. Yes, what are the classes of IP address? Imran says there are four classes. What about others? Yes, Daniel, Ahmed, both are right. There are five different classes: Class A, Class B, Class C, Class D, and Class E. That's right. And can anyone tell me the range of these IP addresses, which we have discussed earlier? What are the range of these IP addresses? Sorry, what are the range of these classes? What is the range of Class A? What is the range of Class B? Put in the chat box. What are the range of these classes? Class A has some range, right? Class similarly class B, C, D, E all has the range defined. So what are the range? Please put in the chat box. Yes, Ahmed has put right. Even Imran has put in the correct way. So 1 to 126 class A range is there. Then I have told you that 127 is the loopback address used for loopback. Then we have class B starting from 128 to 192, class C 192 to 223, and D and E has a specific special purposes which we have already discussed. Right now, now let me write down those things over here, because I told you earlier that whatever we are discussing now is a basic only. Again, everything is going to repeat and in detail. Classes of IPv4 addresses. We have discussed class A, and it is 1.0.0.0 to 126.255.255.255. And we discuss about class B, which was 128.0.0.0 to 191.255.255.255. Then we have class C, which is 192.0.0.0 to 223.255.255.255. Class D, that is multicast, used for multicasting, and the range is 224.0.0.0 to 239.255.255.255. And then we have class E, which is 240.0.0.0 to 255.255.255.255. Is this correct? Not let me tell you one thing. Whatever you are seeing now, these are the classes, right? The IP address is there from specific range to specific range. But this IP address is whatever IP address is also address, kind of the address you have at home. Similarly, is the IP address, the address of the devices. These IP addresses are divided into two fixed parts. Divided into two parts. These IP addresses are divided into two parts. They are network ID and host ID. Now consider you want to send the courier to a specific address. So what happened? You will have the area, right? Similarly, these are the area. Class A has this area, class B has this area, or a boundary, you can say class C has this area. And wherever you are sending the courier to that specific area, in that area you will be having the home number, right? Similar to the home number, over here we have host ID and area is a network ID. So the IP address is divided into a specific area, which is a network ID. That it can be a broader term, a complete network, a complete area, and within that area you will be having the home number, similar known as host ID. So the network ID represent the area where the device belongs, and the host ID is actually the number of the device. If you are using computer, and let's say in your home network you have an address 192.168.1.1, then your phone will be having 192.168.1.2. Okay, can everyone do one thing? What everyone has to do is you have to just type the click on start button, type command prompt, and then do one thing. Give me the IP address of your computer. Everyone, put the IP address of your computer first. Can everyone put their private IP address of their computers in the chat box? Please be quick, guys. Please be quick. Sohail is writing the IP address of his computer as 192.168.1.37. Okay. Daniel says 1.5. Okay. Now everyone do one thing. Everyone do one thing. Just open your mobile phone. Open your mobile phone. Then go to the settings. Then go to the Wi-Fi option in your mobile phone. And to whichever Wi-Fi you are connected, just click over there. You will get an IP address. Please put that IP address also. Everyone open the mobile phone, go to setting, click on Wi-Fi, and to whichever Wi-Fi you are connected, click over there and just put the IP address. Scroll down, you will find the IP address. Put the IP address. Be quick, guys. Yes, Imran, Ahmad, Sohail, Daniel. Be quick. Put your phone IP addresses also over here. Okay, now Sohail has put it. Let's take an example of his IP address. See, his computer IP address, what Sohail has put is 192.168.1.37, right? And he has put his phone IP address as 192.168.1.32. Now see the similarity over here. See the similarity. Sohail has connected the phone and the mobile from one his network, home network, right? Or maybe office network. See the network ID 192.168.1, 192.168.1. Only the host ID is changing. The host is a phone. The host number, home number is 32. The host is the PC. The number is 37. But the network ID remains same, 192.168.1. So it represents his network. 192. The first three octet represent his network, and the last octet represent his number, his device ID. Is this concept clear between network ID and host ID? Anyone has any doubt over here? Okay. So the IP address was divided into two fixed parts, that is network ID and host ID. Now this 192.168.1, we have determined that it is a network ID, but how you can determine directly, that we'll discuss how to determine, and sometime we'll discuss how to identify what is a network ID, what is a host ID, that we will discuss. But now what is network ID and what is host ID, that is clear. That is enough for now. So so if you will see over here, if you will see over here, class A has the IP range 1.0.0.0. So earlier, what used to happen, there used to be a fixed network ID and fixed host ID for each classes. The network ID and the host ID was fixed for the classes in olden time, in earlier time. So if you talk about the class C, like over here, you will see we have taken one example that first three octets remain same, and the last octet is keeps changing, right? So if you want to say that how many network can be there over here, how many network can be defined in this range 192.168.1 dot something. So if you want to calculate that, how you will do that? For that, just remember, IP address has is a 32-bit IP address, right? It is a 32-bit address. IP address is 32-bit address with 4 octets, right? With 4 octets, and has each octet has how many bit? Let's put it in the chat box. Each octet has how many bits? Each octet has how many bits? IPv4 address is a 32-bit address which we have discussed with, and it has 4 octets. So each octet has 8 bits, right? And bits are the combination of zeros and one. So if you want to know that, how many network can be there in this range in the Sohail network which you have written, how many network can be defined? So what you will simply you will say 2 raised to 8, which is equal to 256. So you can define 256 network in this class C range. Now similarly, if you will see the class A address, the first bit represent the network, the 3 bits represent the host ID. So if you are talking about the class A address, then in that case, how you will define? If you want to know how many network address will be there in class A, then in that case, it will be 2 raised to 24, because first bit represent the network ID, rest 3, 8 plus 8 plus 8, 24 represent the host ID. So 2 raised to 24 will be around 16 million hosts. It comes to be 16 million hosts. So over here in this 2 raised to 8, total 256 IP addresses can be used. 192.168.1.37.1.32. So in similarly, you can use 192.168.1 dot starting from 1.0 to 1.255. So 256 IP addresses can be used. You can calculate 2 raised to 8 is 256. But if you want to know that how many hosts will be there in class A, how many hosts will be there in class A, so you will say class A, for class A, first is the network ID, and the remaining 3 are the hosts. So 2 raised to 24, which is approximately 16 million hosts per network. In class A, you will have 16 million hosts. Similarly, if you want to calculate that how many will be there in class B, so the first 2 bits represent the network ID in class B, it will be 2 raised to 16. Class C, we have calculated 2 raised to 8. 256 in each network there will be 256 host ID. Anyone has any question, any doubt over here in network ID, host ID? So, what is network ID? Network ID, it is also represented by net ID. Network ID is also represented by net ID, also known as net ID. It is a fixed bit. Net ID is the fixed bit in the IP address. Network ID is a fixed bit in the IP address that represents the entire network. Similar to the area name will always be fixed, but the home number will keep on changing. So similarly, in the IP addresses, net ID or network ID is a fixed bit in the IP address. It will not change. Like in the Sohail example, in the Sohail network example, you have seen that the first 3 bit. So in Sohail network, it is a class C IP address because it is falling in this range, right? So it is a class C network he is using, and over here you will see that the first 3 bit is same. Only the fourth bit is changing. The network bits always remain same. So a network ID, also known as net ID, is a fixed bit in the IP address that will represent the entire network of any host. Whether the host is his phone, whether the host is his computer, whatever the host is, the network ID will be the fixed bit and it will represent the entire host. That is, it will tell you, the network ID will tell you the host is connected to which network. Now, these are the general terms which I will write. When you talk about class A, in class A, first octet represent network ID. Okay, so you can say that 8 bits are the network ID and 24 bits for host ID, meaning that the first octet will remain same in the class A IP addressing, and from the remaining 24 bits, it can be assigned to host ID. It will be like 1.0.0.0, 1.0.0.1, 1.0.0.255. Then it will start from 1.0.1.1, 1.2, 1.255. Let me write it a few example. It will be like 1.0.0.0.0, then it will be 1.0.0.1 up to 1.0.0.255, then 1.0.1.0, 1.0.1.1 up to 1.0.1.255, and it will go on. So the first 8 bits will remain same in class A, and the remaining uh, 24 bits will be the host ID, and that will keep on changing. Now I have given you example of class A. Now you will tell me what will happen in class B. How many octets will be, how many bits will be the network ID, how many bits will be the host ID in class B. In class B, how many octets or how many bits will be the network ID and how many bits will be the host ID? Yes, Sohail, Danish, Daniel, Ahmed, Allah, you all are there with me. In class B, how many will be the host ID, how many will be the network ID? Okay, let me tell you. In class B, first two octet, first two octet represents network ID. So, yes, Daniel is right, 16 bits. The first two octet represent network ID. So, there will be network ID 16 bits and host ID 16 bits. Okay. Similarly, in class C, the first three octet represent network ID. First three octet represent network ID. So, 24 bits for network ID and 8 bits for host ID. So I can say that since in class A, 8 bits represent, the first 8 bits represent the network ID. So in total, I will be having around 2 raised to 24 host. It is a big network. This which is equal to approximately approximately 16 million, approximately equal to 16 million hosts. So in total, if I am using class A IP addresses, I will be having 16 million devices connected in this network. Similarly, If it is class B, then in that case it will be 2 raised to 16. You can calculate how much it will be coming. And if I'm using class C, then in that case I will be having this many hosts in the network, 2 raised to 8, which is equal to 256. So being a network administrator, it is your responsibility to analyze what is the requirement, how many hosts you will be connecting. If your network is super large, then you will be going with class A subnetting. If it is medium range, then class B. And if it is a small network, then you will be choosing class C as the design. Class D and class E we will not be discussing because they have the fixed bits of network ID. All bits are fixed for network ID in class D and class E, and they are used for special purpose also. So mainly our practicals and all will be focusing on this. Even in subnetting, we are going to discuss about class A, class B, and class C subnetting. Now, now we have discussed about the network ID, the host ID. Network ID, we have discussed that it is going to remain the fix in class A. The first bit represent the first octet represent the network ID, and in class A we have 8 bits of network and 24 bits of host ID, which is 2 raised to 24 is equal to 16 million hosts in class A. In class B, the first two octet represent the network ID, so we have 16 bits of network ID and 16 bits of host ID. In class C, the first three octet represent the network ID, so 24 bits for network ID and 8 bits for host ID. So I think what is network ID and what is host ID you understood, right? Or if you have any questions, please feel free to ask me. Any questions, any doubt? Yes, Imran, what do you mean by host? Please tell me. You have any questions? Okay, so let's move ahead. And if network, see, if there is a small doubt also or any small question also, please feel free to ask, because without having a knowledge on this classes and then the network ID, host ID concept, you cannot understand subnet. And if you cannot understand subnet, you cannot understand subnetting. And subnetting is a powerful tool. Now, till now we were discussing about the IP addresses, that it is the 32-bit IP address. It has 4 octet. Each octet has 8 bits. Everything. But let me tell you, without the IP address is simply a number unless and until you don't define something called as subnet mask, because it is subnet mask which help you to identify what is the network of this IP address, to which network this device belong, what is the host ID. Everything can be understood using subnet mask. Now, if I was saying over here, did you understood why I'm saying 8 bit, 24 bit? No, only theoretically I have explained you. You have just memorized it, but how it comes, we don't know. So that how you identify that the specific IP address, what is the network ID, what is the host ID, you can identify using the subnet mask. So again, a subnet mask. What is subnet mask? Everyone is seeing subnet mask in their computer, right? If you just open the command prompt over here, everyone open the command prompt, and once you open the command prompt, you give a command ipconfig. You will see that there are so many adapters I am having in my computer, and each adapter has an IP address, and to each IP address a subnet mask is associated, right? Everyone might be having the same thing. If you will see, to every each and every IP address, this is the Wi-Fi adapter IP address of my laptop, which has the IP scheme 192.168.198, and then you have a subnet mask 255.255.255.0. So everyone has the subnet mask, right? It is not possible that IP address can be defined without a subnet mask. It is not possible. So a subnet mask is a 32-bit number. Again, a subnet mask is a 32-bit number that separates an IP address into two parts. It is a subnet mask which divides the IP address into two parts. And what are those two parts? Network ID and host ID. See, whatever we have discussed just sometime before was a ratta that class A has this much network ID and this much host ID. Class B has this much network ID, host ID. That is standard, but again, we have to come to the conclusion how that has been defined. So the subnet is a subnet mask which plays the role. So a subnet mask help you to identify that within the specific IP address, what is the network ID, what is the host ID of the specific device. So the subnet must tell the device which portion of the address belong to the network and which identifies the individual device. It is a subnet mask which will actually tell the device to which network ID it belongs and what is the host ID, what is this number. Now, similar to the IP addresses, we have a subnet mask. Now, it is again 32-bit address. Subnet mask is again a 32-bit address, and when you talk about the subnet mask, how you will be writing it is a 32-bit address. Four octets are there, and each octet has 8 bits. So in your PC, the subnet mask which is written is 255.255.255.0, meaning that the first three octet, which is 255.255.255, represent the network, and the last octet represent the host. Now, if I am writing the IP address is 192.168.1.10 with subnet mask 255.255.255.0. So in this case, you know that it is IP address is something the combination of zeros and ones. It is the binary number, right? So if you want to represent 192.168.1.0, how you will write? Yes, can anyone help me to convert it to binary? When we are converting it to binary, 192.168.1.0. So when you write 192, I have explained you how to convert this, right? It will be 11000000, right? Then have we have 168. This we have already learned in first lecture, right? So I don't have to explain. Or you want the explanation again how we are converting this to binary? Please confirm in the chat box. Then we have 168. If we want to convert this, then we will write 10101000. Then we have 1, meaning that 00000001, right? Then there is a number 10, so it will be 00001010. Then we have subnet mask over here. So when you look at the subnet mask, 255 means all will be 1 bit, right? 11111111 dot 11111111 dot 11111111. But if you look over here, it is 0. So using the subnet mask, wherever there is one, that represents the network ID. Okay, wherever there is one, the complete all the bits are one. That is a network ID. Okay, and the wherever there is 0 or a combination of 0 1, that is the host ID. So if I'm writing 192.168.1.10 subnet mask 255.255.255.0, then in that scenario, using this subnet ID, you will uh, be able to identify the network ID and the host ID of the network. So Can anyone tell me that how many bits are in the network and how many bits are in the host for this IP 192.168.1.10? Please put in the chat box. From this, looking at the subnet mask, and I told you that one bit, if all are one, then that is a network that represent the network part, and zeros or a combination of 0 and 1 represent the host part in the subnet mask. So using the subnet ID, can anyone tell me what will be the network bit and what will be the host bit for this IP address 192.168.1.10? Please put in the chat box. Allah says that 24-bit network and 8-bit host. What about others? Okay, so almost everyone has given the right answer. That from this you can determine that 24 bits represent the network and 8-bit represent the host over here. Now, now, what is the function of the subnet mask? Why we should use the subnet mask? We have just discussed sometime before that class A, if you have a class A network, how many hosts will be there in class A network? How many hosts will be there in class A network? How many hosts will be there in class A network? Please put in the chat box. I am talking about host, not about the network. Imran, how many hosts will be there in class A network? The in class A network, first bit represent the network ID, right? And the second, third, and fourth octet represent the first octet represent the network ID. So 8 bit of a network. Yeah. So how we will calculate how many hosts will be there? It is 2 raised to 16. Sorry, 2 raised to 24. 8 bit represent the network, 24 represent the host. So 2 raised to 24, which I told is approximately 16 million hosts will be there in class A address. 16 million hosts. Okay. So, being an administrator, if you are using such a big network where you have 16 million hosts, do you think practically it is possible to manage all these devices? You have built up a network. Being an administrator, you have built up a network, and then in this network you have started to assign the IP addresses either statically or dynamically. Now, do you think that managing the 16 million devices at once is an easy task? Of course, it is not an easy task, right? It is not an easy task. So, using subnetting, what you can do using subnetting, managing the 16 million hosts at one time is next to impossible for an administrator, for a human being. It is not next to impossible. Now, let's say, for example, in your organization, you have 100 departments. Okay, you have 100 departments. Now, you have 100 departments. So there is no necessary that all this department need to communicate to each other for everything, or maybe they will require to communicate, but you have 100 departments. So what you will do, instead of assigning this 16 million host to all at once, you will be dividing, you will be dividing your network, you will be dividing your network into small segments. You will be dividing your network into small segments, which is manageable for you, which is manageable for you. And then what you will do, you will divide the network into small segments, which is manageable for you. And that small divided segments, you will be assigning to individual department. So it is something like, let's say for example, you have you have this, you're using this network, sorry, you're using this network 10.0.0.0 to range 10.255.255.255. For example, you're using this range in your organization. So instead of using this complete range, what you will do, you will say that I will be using 10.0.1.0 1.0 to 10.0.1.255. Then I will be using 10.0.2.0 up to 10.0.2.255. So in some way we will divide it. Now how we are dividing, that we will learn in subnetting. This is only what we have to learn exactly in subnetting. But for now, just understand that you have such a big network, and managing those network, being a human being, is next to impossible to manage 16 million hosts at once. In your organization you have 100 of departments. What you will do, you will divide your big network into small network. And this dividing of the big network into the small network is nothing but subnetting. Okay, whenever you divide the network into a small networks, this is nothing but subnetting. So you got an idea, right? What is subnet, what is network id, what is host id, what is subnet. So concluding, I can say over here about the subnet that subnet mask is a 32-bit numbers, 32-bit numbers made of ones and zeros. Ones identify the network, zeros identify the host. Zero identify the host. Now, let's say I am writing on subnet mask. I am writing on subnet mask. This is, I am writing it in binary. Okay, I am writing it in binary. Can anyone tell me what will be the subnet mask of this? If I am writing this in binary, what will be the subnet mask? Please put in the chat box. I have written the subnet mask in the bit format, zeros and ones, in the binaries. Can someone convert it for me? Do you remember in the first lecture I have shown you how to convert it to binary by dividing the number to 2. We kept on dividing and we got the binaries, that is the bits combination zeros and 1. Allah says that 255 not 255 not 255 not 192. What about others? Now I have shown you how to convert the hexadecimal to binaries. Now let me tell you how you will be adding this. Always remember, it is a 8-bit address, right? It is a 8-bit address. And since it is a 8-bit address, I have also told you that the first bit is 2 raised to 0, or else let me just write it over here. I have given you some hints. One will be the first bit will be 2 raised to 0. Second is going to be 2 raised to 1. The third is going to be 2 raised to 2. The fourth over here is going to be 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. Now, just take this number 1, 1, and then all are 0, 0, 0, 0, right? So just write down over here 1, 1, then all are zeros. 0, 0, 0, 0, 0. This is what I have written, right? Now you can calculate. These are zeros, so just leave this. 2 raised to 6. How much is 2 raised to 6? 64. And how much is 2 raised to 7? 128. So 128 plus 64 is 192. And rest all are 0. And this 11111, this is always going to be 255, right? This is going to be 255. So the subnet mask, when you will write it over here, so it is going to come. What happened? Once again, this will be 255.255 dot 255 dot 192. That is 128 plus 64. Now we will make a more practice on this, because I think that you need this. Before we move to subnetting, I want you to be well prepared. Daniel, Danish, Ahmed, Imran, Sundus, everyone is there with me. Allah. Now if I write the binary as 10101, so tell me what is going to be the number over here if I want to convert it. Please convert it and write it in the chat box, because this is very important. If you want to learn subnetting, you have to be very much expert in conversion of this binary to hexadecimal and all. What is going to be the number over here? Ahmad says 168. What about others? Daniel says 168. Yes, everyone is almost right. Now, Convert this number. Convert this number which you are seeing on the screen. Convert this number and tell me the answer. Do you think 37 is right? Okay, let's verify. The first bit is 1, meaning that 2 ratio 0 is 1 plus. Second bit will leave it. The third bit is going to be 2 raised to 2, which is going to be 4. Fourth bit is 0. Fifth bit is 0. Sixth bit is 2 raised to 5. How much it will be 2 raised to 5? 32. Okay. Now, if I will give this, please calculate this. That's right. Now, we will take a short break and then we will continue. So, we'll take a break for 5 minutes. Don't log out. Just keep it as it is. Keep logging. Take a break for 5 minutes and then we'll start. So, till now, we have understood like how the subnetting works. We have discussed that subnetting is a concept where we divide a large network into a smaller subnetworks. And when you divide a network, yes, of course, the subnet mask will change, and that is something called subnetting. How we will do the subnetting, that we are going to learn in the coming time. But before we learn how to do the subnetting, it is important to understand the prerequisites. What is network ID? What is host ID? Which we have already discussed. We have discussed why the subnetting is required. What is subnet mask? We have discussed why the subnetting is required. We have discussed. We have understood one concept like if you have a huge numbers of hosts within the network, it is very difficult to manage all those hosts. That is the reason you divide the network, the big network, into a small networks as per your requirement, which is the job of a network administrator. This is one of the purpose which we have discussed for doing the subnetting. There are some other purposes also. There are some other purposes also for doing the subnetting. Now, we everyone knows that if let's say, for example, within your network you have a switches. Network switches are there. This is a network switch. This is a network switch. This is a network switch. There are, let's say, there are hundred of network switches. There are hundred of network switches. This is switch. this is switch, and then this is also switch, and there are thousand of end user PCs, laptops, computers, telephone, everything is being connected in your network. This everything is interconnected. This is how something, it's a very bad in looking, but just for understanding, it's some sort of network where you have 100 to 1000 of switches, and then hundred thousands of end users, laptops, mobile phones, everything is connected over a network. We have learned that. Now let's say, for example, in switch, what happened? This is a user one. Let me just let's say this is a user, and this user want to talk to this user. What is going to happen? This user, the traffic will come on the switch. What switch does? Switch will broadcast. It will send to all the devices in the network, to all the devices within the network. And once this will broadcast, what will happen? The broadcast will go here, it will go here, 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 everywhere it will go, right? So now assume that you have hundred of switches and thousand of devices connected. So what is going to happen over here is, if you this specific device want to talk to this specific device, rather than going over from here to here, it will be broadcasting. Unnecessary broadcast will be there, which may cause a network congestion. This switch will keep on asking, who is this, we have learned about the ARP address, right? So whose IP is this? So everyone will respond, says everyone will reject, this will respond. But the problem is, the broadcast will be going to each and every node, each and every switch, everywhere it will be going. So do you think that this unnecessary broadcast is actually required? To be very honest, it is not required. So if you do subnetting, which means that you are dividing a big network into a smaller network, so what is going to happen? Whenever this device want to talk to a specific device in other network, as the routing will happen over here, inter-VLAN routing, which we are going to discuss, that is going to happen over here. And there will be, the broadcast will be limited, because the broadcast will never pass from one network to another network. That also we have to discuss. But just for your basic understanding, let me tell you one thing, that using subnetting, you can also reduce the network congestion. You understood the pain areas, right? The broadcast will go everywhere, that broadcast will be stopped over here. This is one thing. The management becomes easy. Now let's say, for example, if you have 100 networks, 100 department within your network, what you can do, instead of using one single network, you will divide the network into small 100 networks, and you will assign it to each and every department. So during the time of troubleshooting, it will be easy for you to recognize that the specific network belongs to which department. So these are all the advantages of the subnetting. Now, as we have discussed earlier, Internet Assigned Number Authority (INA) is the one who is assigning the IP addresses and all. INA, right? Internet Assigned Number Authority. Numbers Authority, also known as INA. This is the organization who is responsible for allocation of the IP addresses. Who is responsible for allocation of IP addresses? Now, what they have done is, IP addresses they have divided into classes, right? Class A, class B, and class C, which is being commonly used. Class A, class B, and class C are the IP addresses which are commonly used. Class A, class B, class C, which is commonly used by the end user. End user means your computer, you are assigning the IP address, your laptops, your mobile phone. So these are the IP address range. It can be from class A, it can be from class B, or it can be from class C. Class J and Class E exist, but that is not for end user, because Class J is something used for multicasting that we are going to learn. Although that is not a part of CCNA topic, but I will be taking that as well. And then Class E is for some scientific research and all. Now, what they have done some standard approach. They have done. They said that for Class A, the default subnet mask. Let me write down one thing. Let me write down something for you over here. What they have done is, there's some problem with my, just hold on. Shit, yeah. Okay, they have given defined sub default subnet mask. They have defined for a specific address range in the specific classes. And then, of course, there will be number of hosts. This we have already learned how to calculate the number of hosts, right? So when you talk about class A, it has defined the default subnet mask as 255.2.0.0.0, meaning that the first bit represents the network ID, and the remaining three, the first 8 bits represent the network ID, the remaining 24 bits represent the host ID. And then we have the address range, which is starting from 1.0.0.0 to 126.255.255.255, correct? And in this class A, the number of hosts is 16 million. 2 raised to 24 is 16 million. Then for class B, the default subnet mask is 255.255.0.0, and the address range starts from 128.0.0.0 to 191.255.255.255, and the number of hosts is 2 raised to 16, meaning 65,000. Yes, 65,000 number of hosts. And then we have class C, which has default subnet mask 255.255.255.0. The address range is 192.168.0. Sorry, 192.0.0.0 to 223.255.255.255, and the number of hosts we have already calculated. is 256. Actually, wherever if you go to the internet, if you go to the internet and browse some content, they will show instead of 256 it will be 254, which is correct. But for now, just say 256 because we have not learned subnetting, how to do subnetting. When you learn that, then you will realize that why it is 254. But now let's say 256 for now. 256 hosts are there in this. Any questions? Any doubts till here? What about others? Dania, for Daniel, it is clear. What about others? Is it clear for everyone? Now, subnetting. What is subnetting? You understood. What is subnet mask? You have understood. What is network ID? What is host ID? You have understood. Now we are going to start learning what is how to do subnetting. But I think that if I start now, we will not be able to complete. So we will keep this for next week. But before we leave, let me tell you something. Let me tell you something. You have learned subnet mask is a 32-bit number. It is a 32-bit number used in IP addressing to separate the network portion and the host portion of the IP address. Subnet mask is a 32-bit number used in IP addressing to separate the network portion and the host portion, meaning that it helps you to identify the network ID and the host ID. The ones bit in the subnet mask represent the network portion, zeros represent the host portion. This we have already discussed. There is something called as CIDR. There is something called as term CIDR. So CIDR stands for classless interdomain routing. What this is, we'll discuss later. And there is something called CIDR notation. So what is this? See, subnet mask, how you're writing 250, for example, you're writing 255.255.255.0, where you say that 24 bit is network ID and 8 bit is host ID, right? So instead of that, what you can do, writing such a long mask, you can just straight away write the CIDR notation, also known as prefix length. Instead of this, what you will do, if you want to write subnet mask, instead of that, you can simply say slash 24, only the network ID. If you write this slash 24, it is equivalent to this 255.255.255.0, meaning that slash 24 means this is the network ID of this specific IP address. Now, if I have a subnet mask 255.255.0.0, can anyone tell me what will be the CIDR notation for this subnet mask? Please put in the chat box. Ala and Ahmed says slash 16. What about others? That's right. And Ahmed is super fast. He has given something beyond my expectations. That's good. Anyway, so this is how are the prerequisites which were required to go ahead and learn subnetting. And remember that subnetting is again a very powerful and important topic, because this is something which you will require everywhere.